sklearn, cluster. Agglomerative clustering. Description. Agglomerative clustering is a hierarchical clustering algorithm that builds a hierarchy of clusters by progressively merging the closest clusters. It starts with each data point as a separate cluster and iteratively merges the two closest clusters until a specified number of clusters is reached. Inputs: n clusters, the number of clusters to find. If not specified, the algorithm will determine the optimal number of clusters using a metric like the silhouette score. Affinity, the metric used to compute the linkage. It can be Euclidean, Manhattan, cosine, etc. Linkage, the linkage criterion to use. It can be WOD, complete, average, etc. Outputs: labels, an array of integer labels corresponding to the cluster membership of each data point. N clusters, the number of clusters found by the algorithm. Steps: initialization, each data point is assigned to its own cluster. Merging, the two closest clusters are merged based on the linkage criterion. Iteration, steps 2 and 3 are repeated until the desired number of clusters is reached. Metrics: silhouette score measures how similar a data point is to its own cluster compared to other clusters. Kalinski-Haraba's index measures the ratio of between cluster variance to within cluster variance. Visualization plots: dendrogram, a tree-like diagram that shows the hierarchy of clusters. Scatter plot, a plot of the data points colored by their cluster membership. Fine-tune parameters: n clusters controls the number of clusters to find. Affinity allows choosing the distance metric to use for clustering. Linkage specifies the criterion used to merge clusters. Uncertainty methods: bootstrapping can be used to estimate the uncertainty in the cluster assignments. Challenges and fixes. Challenge 1: sensitivity to noise and outliers. Sample use case: a small number of noisy data points can significantly distort the clustering results. Fixes: preprocessing data to remove noise and outliers. Using robust distance metrics like Manhattan distance. Challenge 2: computational complexity for large datasets. Sample use case clustering: a very large dataset can be computationally expensive. Fixes: using a subsample of the data for clustering. Utilizing parallel processing techniques.